The default values for value types has one primary simple rule. All numeric types have a default value of 0 in the appropriate form for the type. For example, an int defaults to 0, the integer value, a decimal to 0.0m with the suffix, and a float to 0.0f. So the other rules then are really just variations of that one simple rule. So the default value for a Boolean is false. But this is roughly equivalent to 0, so that's consistent with the numeric type rule. And then the default value for a char, a single character string in essence, is /0, \0 actually, which is the escape value for a null, which is not 0. It's the escape value for a null. All right, so that's pretty much it. There are some variations for more advanced types, such as structures, but you really don't need to worry about those for now. All right, so that's all the theory. That's essentially how it should work. But C# has some kind of strange behaviors in this regard. What's strange about it is that the C# compiler won't let you use any variable that isn't explicitly initialized or set to a value. If you do, you'll get an error. So what I'm going to do is I'm declaring this myInteger variable. I'm going to uncomment this line of code here, where I'm attempting to use the value of myInteger without explicitly initializing it. Now in theory, myInteger has a default value of 0, so I can just go ahead and use that value, and it would display myInteger equals 0. But that's not how it works. If I hover over that statement there, that expression there with a red squiggly, never a good sign in C# code, it says use of unassigned local variable myInteger. Compiler won't compile the application. I can't run it. Okay, so I can understand that. You know, it's good to make me initialize my variables and have everything proper and be explicit about it and so forth, but it kind of gets even weirder. So I'm going to comment that out once again. And then I'm going to put a breakpoint on that statement right there. So in this case, when this breakpoint stops, I've declared my integer, so that's a variable in memory. Memory's been allocated for the size of an integer, but I haven't done anything with it yet. I changed the value right there, but the breakpoint stops before the statement executes. All right, so I'll go ahead and run the application. And I'll select N for default values. All right, so we've paused. And I can hover the cursor over here, and as you can see, IntelliSense tells me that my integer has a value of 0. So C# is doing what it claims it does, but the compiler is preventing me from doing this because I haven't initialized that variable. So this is definitely a case where the compiler is being kind of a bit overprotective. It's kind of a hovering parent and kind of getting in my way a little bit. But really, most of the time, that's a good thing. It helps you write bug-free code. Code where you explicitly initialize variables is more readable, more maintainable. It conveys what your intention was, rather than somebody coming along and saying, oh, my integer, Don forgot to initialize that variable. What an idiot. Okay, no, I intended it to be 0, but the compiler wouldn't let me do that. So I need to explicitly initialize it. All right, so uninitialized variables have a default value, but the compiler won't let me use them without initializing them. Well and good. So how do you initialize them? Well, there really are 3 easy ways around the problem if you really truly want to use the default values, all of which involve initializing the variable. You have to have an assignment operator before the compiler is happy. So you need to do it either at the same time as you declare the variable or sometime thereafter, as long as you initialize it before you attempt to use the variable, before the first time you try to read it. All right, so the first solution is to use the C# default keyword. This returns the default value of the type that I pass in as a value to that object. So I can say int myInteger is equal to default for an integer. and that'll set it equal to 0 because the default for an integer value is 0. Second way is to use the new keyword to instantiate an instance of the type in memory that has the default value. All right, now you'll learn more about this keyword when the course covers classes and objects in detail, so don't worry about the details for now. But you can use a statement like this. You do what's commonly phrased as new up an int, so this is newing up an integer. Behind the scenes is running the constructor for that object and setting that value to 0, and then the value of that new object becomes the value of my integer. So that's essentially what's happening. Don't sweat the details for now. You need to understand about classes and how to instantiate classes and how they work and constructors and so forth before this is going to make any sense. But I wanted to be comprehensive here. Okay, and then the third option is you can always just go ahead and explicitly initialize it with the default value, which in this case I would say my integer equals 0. So probably the most common way that you'll do this is by explicitly initializing the value. I don't remember the last time I saw a developer use default int or even new int. I'm sort of attracted to the second option, using new, because that's kind of how you initialize other classes and then assign a reference to the class to the variable. But my integer is a value type, so you're not saving a reference to a new object, you're actually saving the value. So there's a disconnect there. But really, generally in my code, I just go ahead and explicitly initialize it to the default value. Makes it real clear, real simple. It's 0. I don't have to stop to think what the default value for an integer is, or probably in a Boolean, I often have to stop. Is it true or false? Of course it's false. And I always remember, but it just gives me pause. So, the less amount that I can pause as I'm reading code, the better off I am. All right, but any of these techniques work for any of the value types. So here's some code that shows off those different methods of initializing a variable to its default value. So here I'm using the default int to set it to 0, newing up an int, and setting it explicitly to 0. Okay, so I talked about those. And then here are a few more data types. These are all value types. So double my double to the default of double, char my char to the default of char, and bool my bool default of bool. And so this is just going to display those different values. So my integer is 0, my double is 0, my char, that's not going to show anything because the null character that is the default for my char is not a visible character. You can't type it on your keyboard, so it's not going to show anything. And then my bool is false. All right, so I'll go ahead and run this and hit N for default values again. And there you can see my integer is 0, my double is 0, my char is null value, and my bool is false. Default values for reference types are a bit more interesting than for value types. These are the types that are set to the null value by default, which are indicated by the null keyword. This indicates that the variable does not refer to any valid object. Remember, a reference type stores a reference to an object. Null means that it doesn't have a reference to an object. So any reference types that you declare without initializing them will have a value of null. And that includes strings, object variables, classes defined in the .NET framework, as well as custom classes that you define. So the rest of the code in this method deals with reference types. So here I'm declaring a string variable, myString, explicitly setting it equal to null, and an object, myObject, explicitly setting it to null as well. And so this sets the default value, but you can use the other methods of defining a null as well. So here I'm explicitly setting it to the value of the null keyword. Then the code displays the values. So my string is whatever the string is, null. My object is my object, which displays nothing. They're blank because null is not a displayable character. And then it goes on to compare the object to the null value. Again, using this null keyword. So if my string is equal to null, then it displays this. And in fact, it is going to display that because my string is null. I haven't initialized it to anything else but null. Otherwise, it displays my string is whatever. If my object is equal to null at this point, it's also going to be null. It's going to display that. It's not going to execute this line of code. But then where it gets interesting is this line right here. So now what I'm doing is I'm setting the value of my object to a reference to my integer. Because that's a value type, when I read the value of my object, it's not going to be null any longer. It has essentially a memory address of my integer, wherever that's located in memory. All right, and then once again, it compares my object to null. This time, this line of code is not going to execute. Instead, this one is going to execute, and it's going to say my object is the value of my integer, which if we come back up here and see, my integer is equal to 0. All right, so I'll run this once again. Press N. So now we can see my string is null. That's not displayable. My object is not displayable. My string is null, but the only reason it says that null there is because I used in the console write line literally my string is null. I spelled it out, space N-U-L-L, and did the same thing here. And then when I set the value of my object to my integer, now it's reading the value of my integer, and my object returns the value 0. Okay, so again, to emphasize that point, I included this literal string that said my string is null. Whereas up here, it was displaying the null value, which doesn't display because it doesn't display within the console window. And you can also set a reference type to a null value, much as I did here. So if my string was previously set to some string, like literally double quote Don Kiley double quote, I could change it to a null by doing an assignment of the null value. As weird as nulls may seem, especially if this is your first encounter with the concept, they're enormously useful when working with reference types in C# code. So a string, for example, can have 3 distinct states. It can contain a string of 1 or more characters. That's what a string is. It can contain the empty string, literally double quote with nothing in between. And it can contain the null value. Now, it's important to understand that assigning a null value to a string is quite different from assigning it the empty string. A null value indicates that there is no value, while the empty string is a distinct value. This can be pretty useful. For example, a middle name variable can be set to null, and that could mean that the person's middle name is unknown. We just don't know what it is. While the empty string could mean that she has no middle name. But you can choose to interpret these values in any way that makes sense for your application. Working with nulls requires some extra work, such as conditional blocks of code to display meaningful data to the user in a console window.